All right. So this is our first notes. Okay. So today we are starting with sets chapter. All right. So what is a set? So a set is a well-defined collection of objects, right? Now, what do we mean by well-defined collection of objects? By well-defined collection of objects, it should be same for everyone, right? For example, the set of the collection of first 5 prime numbers is a set because it's same for, if you ask that question to me, the answer would be the same. If I ask the question for Pawan, it would be the same, right? So for everyone, the answer is going to be the same, right? That is the meaning of well-defined collection, right? Now, what about something which is not an example of well-defined collection? Uh, let's say if I ask you the question as, collection of famous prime numbers, right? Well, in that case, what happens is the answer differs based on the person, right? For me, the famous 5 numbers could be 2, 9, or 2, 7, 11, and 17. For you, it could be other set of numbers, right? So there is no one answer, right? So that is not a well-defined collection. Yeah. So this is the meaning of well-defined collection. Yeah. Now, how do we represent sets, right? So there are two forms. The first one is the roster form. The name is not important here, okay? Just try to understand the logic, like, the way it is represented, right? So what is happening in the roster form? What do? We simply represent the elements separated by commas in the curly braces, right? So we use these curly braces, and within these curly braces, we write all the elements separated by commas. And the most important thing is we should not repeat the element, right? So while writing the set in the roster form, an element is not repeated, right? You should not write 5 more than once, right? You should write only once, okay? It should not be repeated more than once. So for example, yeah, if we have to write the set of letters of the word Mississippi, so how I'll write? Basically, there are only 4 letters, like 4 distinct letters, right? So I'll have to write only 4 of them separated by commas in curly braces, right? That is my roster form. Next, we have something called set builder form. Again, this is very important, right? So what are we trying to do in set builder form? We are trying to write the set, or we are trying to mention the set using its definition. Okay. So in this, we write down a property or rule which gives us all the elements of the set, right? For example, here we have set A, which is X, such that X belongs to natural numbers, right? N stands for set of natural numbers and X less than or equal to 5. Now, if I want to convert this into roster form, it will be 1, 2, 3, 4, 5. Now, instead of writing in that way, right, instead of writing all the elements separated by commas, what am I doing? I'm representing the property of those numbers. Is it clear? Both of you, Dimpu and Paul? Yeah.
Yes, sir.
Yes. Okay. All right. Now we have first question. Yeah. Do you have any doubts in the first question?
No, sir.
All right. So it's a simple question, right? So we just have to write x cube, where x is a whole number and x is less than 5. So whole number start from 0, right? So in the list form, it will be 0 cube, 1 cube, 2 cube, 3 cube, 4 cube. That's it. You can evaluate them, right? So this will be your answer. All right. What about the second one? Express set B in set builder form. Yeah. How do we write this in set builder form? Anyone tell me? We have 2, 5, 10, 17, 26.
X. X such that X belongs to. Hello.
Yeah, tell me, Pawan.
Belongs to N.
N.
Comma X.
And X.
X square plus 1.
X square plus 1. Okay. All right. X such that X belongs to N and X is equal to N square plus 1. That's it?
Yes, sir.
Are you sure?
n square plus 1, sir.
Yeah, n square plus 1 only. Like, is this the end? That's
Yes.
it. See, here
Yes,
you made
sir.
one mistake. If this is what you are saying, then what I'll consider? I'll consider 1 square plus 1. Okay. Then I'll consider 2 square plus 1. Then I'll consider 3 square plus 1. Then I'll consider 4 square plus 1. Then I'll consider 5 square plus 1. Then I'll consider 6 square plus 1, 7 square plus 1. This will never stop.
Yeah. Yes, sir. X less than 5. X less than or equal to 5.
S less than. So there are multiple conditions here. Okay. First of all, X such that, all right, X equal to N. Okay. First I'll equate it to N.
Yes,
Right.
sir.
Where, or let's follow, yeah, where X is equal to N square plus 1. Okay. X such that X equals to N square plus 1, where N belongs to natural numbers and N less than or equal to 5. Understood, Pawan? How you have to write? Okay.
Yeah. Yes, sir.
X such that X is equal to N square plus 1. This we have to write in the first step itself, because that is the basic definition. Now we have to impose the conditions on N. What is N? N can take natural numbers less than or equal to 5. Got it?
Yes,
Dimpu, did
sir.
you get it?
Yes, sir.
Okay, this is a good question. Okay. All right. Now let's move to the third question. What about third question? What is its answer?
X such that X is equals to 1 by n square, where n is equals to odd number, 1 less than n less than is equals to 9, sir.
See, always you remember one thing, right? Always we should not write, okay, whatever you're saying, x such that X equals to 1 by n square, where N is a odd number. This is what you are saying, right?
Yes, sir.
So we should try to avoid saying that it is a odd number. Okay, we have natural numbers, whole numbers, integers, these sort of things are there. So we should try maximum to maximum possible extent to avoid using odd numbers. Okay. Now instead of this, the way I'll write it is X
Natural
such
numbers.
that X equals to 1 over 2n plus 1 whole square, right? Where n is a,
Belongs to.
sorry, where n belongs to natural numbers and n less than or equal to 4. Right? Now what is happening when I see, I'm using the same thing that you said, Dimpu, right? Instead of using odd number, I'm writing the odd number here, which is my 2n plus 1 whole square. All the odd numbers are of the form 2n plus 1. Now what is happening? The first element I'll have to substitute n equal to 1. So 2 into 1, 1, 1 plus 2 into 1, 2 plus 1, 3. 3 square is 9. So it's 1 by 9. Then I have to go with 2. 2 twos are 4, 4 plus 1, 5. 5 square is 25. And then I'll have to go with 3, right? 2, 3 is
7
6,
square.
7 square, 49. And then I'll go with
9 square,
81,
81.
right? So this is how I have to represent it. Understood, Dimbu?
Yes, sir.
Yeah. So try to avoid using odd number, even number things. So you just have to use natural numbers, whole numbers, these sort of things.
Okay,
All
sir.
right. Okay. What about fourth question?
Doubts are a question.
Doubt. Okay. Dimpu, did you solve it?
No, sir. I also had a doubt, sir.
Okay, fine. No problem. Let's solve it. So what is the question saying? The number of elements in the set A comma B ordered pair such that 2a square plus 3b square equals to 35, where AB belongs to integers. Where is it? Now we have to find how many number of that such elements are there where A comma B is a ordered pair which satisfy this equation. Okay. Now, one thing is clear for us. What is it clear? That A, B are integers, right? Right. So if A, B are integers, we have to do this problem by trial and error only. There is no other method. Okay. So first, let's say the value of A square is 0. Okay. Then let's try to find the value of B. Right. So if A square is equals to 0, then 2A square plus 3B square equals to 35 will become 3B square equals to 35, which will become B square equals to 35 over 3. But is this possible? B square being equal to 35 by 3, is it possible?
No, sir.
No,
sir.
because B also has to be an integer. So this is not possible. So A square equals to 0 is straight away ruled out, right? Then let's use A square equals to 1. In that case, what will happen? 2A square plus 3B square equal to 35 will become 3B square equals to 33 and B square will be equal to 11. Right? Again, this is not
Yes, sir.
possible because I'm not getting B as the integer. So this is also not possible. So A square equals to 0 is not possible. A square equals to 1 is also not possible. Then I'll go for the next number, which is A square equals to 2. But A square cannot be 2 because A square also, A has to be an integer. If A has to be an integer, A square cannot be 2. Right?
Yes, sir.
Understanding this point, Dimpu?
Yes, sir.
Yeah. Okay. So A square cannot be 2. A square cannot be 3. A square can take 4. Okay. So the next value that A square can take is 4. If A square is 4, then what do we get? 2A square plus 3B square equals to 35. 3B square will be 2 4 8. So 27 and B square is 9. This is possible. Right? Because if A
Yes,
square
sir.
is 4 and B square can be 9, both I'll get integers. Right? But here, how many ordered pairs I can get? I can get 4 ordered pairs. How can I get 4 ordered pairs? If A square is equal to 4, what can be the value of A?
2, sir.
Only 2?
-2 also, sir.
Yes, A can take 2 comma minus 2,
Mhm.
right? Because
Yes, sir.
if A square equal to 4, then A square minus 2 square equal to 0. A plus 2 into A minus 2 equals to 0, which implies either A plus 2 equal to 0, that is A equal to minus 2, or A equal to 2. Okay. So when A square equals to 4, A is equal to minus 2 or 2. And in the same way, B square equals to 9, that implies B is equal to
3 or minus
3 or minus 3. So,
-3.
yeah. So in total, how many possibilities I'll get? I'll get 4
2.
possibilities. What are those 4 ordered pairs? It can be minus 2 comma minus 3. It can be
2,
minus 2 comma 3. It can be 2 comma minus 3. And it can be 2 comma 3. So these are the 4 ordered pairs that I'm getting. Clear?
Yes, sir.
Now, we are still
Yes,
not
sir.
yet done, right? We are not yet done. Still there can be more possibilities. Okay. Let's explore them as well, right? But as of now, we got 4 ordered pairs. So these are the 4 ordered pairs, right? So we took A square as 4. Now, what is the next value that we can take? We can't take A square 5. 6 we can't take. 7 we can't take. 8 we can't take. 9 we can take. When we take A square 9, the roles are getting reversed. Last time we took A square 4 and we got B square 9. This time we'll take A square 9. What will happen? 2 into 9, 18. 35 minus 18 is? What is this? 35 minus 18? 17.
17.
So 3B square, can it be 17? No. This is straight away ruled out. So again, this time also not. Now, what is the next value that I have to take? I have to directly take the next value of A square as 16 because there is no square after 9 till 16. So A square is 16. Now, if A square is 16, then I'll get 2A square plus 3B square equals to 35. That means I'll get 3B square equals to 3. That means I'll get B square equals to 1. And B square equal to 1 is perfectly possible. Yes or no?
Yes, sir.
Yes, sir.
So we got a square equal to 16. That means a can take either 4 or minus 4. And b square equal to 1. That means b can take either 1 or minus 1. So again, how many ordered pairs I'll get? I'll get again 4 ordered pairs. What are those? 4, 1, 4, minus
4,
1,
minus 1,
4,
minus 4,
1, and minus 4, minus 1. That's it.
yes, sir.
Now, can I continue further? No, I cannot continue further. Why can I cannot continue further? Because the next square is 25. 2a square itself is becoming 50. Now, for 50, I have to add some number and it has to become 35. That's not at all possible. So I'll stop it here only. So how many ordered pairs I got? I got 8 ordered pairs. So option C is my right answer. Understood?
Yes, sir.
Yes.
Any doubts?
No, sir.
Okay. So you have to do this question again on your own. All
Okay,
right?
sir.
Yeah, you have to do this
Yes,
question.
sir.
Okay. Fine. Yeah, let's go to the next. So type of sets, right? Null set or empty set, right? A set having a no element, that is your empty set or null set, and this is how we represent it, right? Two representations, very important, you should remember them. Okay. What is the example? This is the example. X such that 0 less than x less than 1, where x is an integer. There can't be any integer lying between 0 and 1. So this is an empty set. Okay. Next we have something called as singleton set. So singleton set, as the name itself suggests, there will be only one element, right? A set consisting of a single element is called a singleton set, right? Then we have something called as finite set. Finite set means a set which has countable number of elements, right? If you are able to count, then that will be called as finite set. Okay. So set of prime numbers less than 10. Then we have something called as order or cardinal number of a finite set. Now, what do we mean by order or cardinal number of a finite set? This is very simple. The total number of elements present in that set is called cardinal number or the order of that set. Okay. What you have to do, you have to simply find how many number of elements are there in that set, and that will be your cardinal number or order of the set. Okay. Then we have infinite set. What is infinite set? A set in which you can't count the numbers, right? You cannot completely count the numbers. Okay. So set of natural numbers, you cannot completely count them. Set of whole numbers, set of integers, real numbers, rational numbers, all these, right? Yeah. Now what about fifth question? Tell me. Fifth question answer. Dimpu, Pavan.
B is an empty set, sir.
Okay. So let's see. We have to find which of the following is an empty set. See, first of all, option C and option D are straight away ruled out, because option C is a singleton set, because in what you'll have 0 in this, right? 0 as an element, right? Because 0 plus 4 is 4, right? And x belongs to real number, 0 belongs to real number. What about this? This is also a singleton set, right? This is what 2, this is 1, right? So this is
One.
now we have to check option A and option B. Okay. So option A, let's say option A. X belongs to R. Okay. X should be a real number such that x square equal to 9 and 2x equal to 6. That means both of them should follow. That means I have to find the value of x in such a way that when I square it, it should be equal to 9. And when I multiply it by 3, it should be equal to 6. Both the conditions should be simultaneously followed. Okay. So x square equal to 9 implies that x can be plus or minus 3. Right? X can take either 3 or minus 3. And 2x equals to 6 implies that x equal to 3. So that means x can take 3. When the value of x is equal to 3, both x square is equal to 9 and 2x is also equal to 6. Therefore, this set will be set containing element 3. Now, what about option B? Again, when x square equals to 9, x is equal to plus or minus 3. But when 2x equals to 4, x is equal to 2. And we can clearly see that there is no common element in both of them. That means this set is an empty set. So option B is the right answer. Understood, guys?
Yes, sir.
So whichever question you are not able to do on your own, you have to do them again. Okay? Yeah. What about sixth question?
B is not a null set, sir.
Sorry?
Hmm.
B, sir, option B.
Option B. Okay. Which of the following is
Yes, sir.
not a null set, right? We have to find something which is not a null set, right? Set of odd natural numbers divisible by 2. So, are there any odd natural numbers that are divisible by 2? The definition of odd natural numbers is itself that they are not divisible by 2. Okay, so this is a null set.
Empty set.
Yes.
Right. Set
Yes.
of even prime numbers. Yes, there is one even prime number. What is that one even prime number? 2. So
Two.
this is not a
Sir.
null set. So this is our answer, right? So option B is our right answer. Okay. Seventh question. Which of the following is a singleton set?
Option C, sir.
Option C. Yes. X square equals to 1 means x can be plus 1 or minus 1. But he said that x belongs to natural numbers. So we will consider only 1. So
One.
therefore, option C is a singleton set. Okay, good. Okay, eighth question. What's the answer? Yeah, tell me.
A infinite set, sir. B finite set, sir. C infinite set.
Yes, sir.
Okay, so the set of lines which are parallel to x-axis. This is clearly infinite.
Uncountable.
Yes, because we can keep on. The set of letters in the English alphabet, it is finite,
26.
right?
Yes.
What about the set of animals living on the earth? Is it a finite or infinite set?
Infinite.
Why
Infinite,
is it
sir.
infinite? Or why is
The
it?
animal lives and dies.
Huh?
The animal production పెరుగుతూ ఉంటది కదా సార్.
No, see, at this moment, the set of animals living on this earth, at this moment, right? ఈ మూమెంట్ లో కన్సిడర్ చేస్తే పవన్ ఫిక్స్డ్ ఎలిమెంట్స్
sir.
ఫిక్స్డ్ ఉంటాయి కదా, నువ్వు అవి కౌంట్ చేయగలుగుతావు కదా,
Yes, sir.
అవునా కదా? కౌంట్ చేసే పాసిబిలిటీ ఉందా లేదా? యూ కెన్ కౌంట్ దెమ్. It is not like something like stars, right, where you can't count them.
Yes, sir.
This is a fixed number. You can definitely count them. Okay, but you will not have the ability to count them. Manaki ఏంటంటే we don't have the equipment or whatever it is we do. But still, they can be countable.
Okay,
Right?
sir.
Yes, sir.
At this moment, ఇప్పుడు ఒక మూమెంట్ లో నేను ఈ టైం ని ఫిక్స్ చేస్తే, ఈ టైంలో ఎర్త్ మీద ఉండే ఎనిమల్స్ అన్ని ఫిక్స్డ్ ఎనిమల్స్, అండ్ ఐ కెన్ కౌంట్ దెమ్, రైట్?
Yes, sir.
సో దిస్ ఈస్ ఏ finite set. Understood?
Yes,
Yes,
sir.
sir.
Okay. Fine. So that's it, guys. Let's stop for time being.